All right, hi everybody. This is Mr. Valconi. I know this is weird. It's weird for you. It's weird for me. But sometimes weird is good. Sometimes weird encourages growth. So I want you to enjoy this experience. I want you to feel it in your mind and feel it in your heart. And hopefully we both learn a little bit about something. You come here to learn science, but deep down, I think I want you to learn a little bit about you. And hopefully this lesson helps that. Okay? All right. Are we good? We're good. Make sure you take out lesson 12.3. We're looking at lens technology in the human eye today. Sorry to have to do this to you guys. I don't want to be away, but I just don't want to fall behind. So let's get this party started. Today is going to be fun. Oh my gosh, look at those eyes. Look at this. Oh, I know there's a lot to copy, and just a note to the supply teacher, or the teacher that's in the room, I'm sorry. Whatever pace I'm going at, if it's a little bit too fast for the students, please just feel free to pause the video, allow them to copy, and then we kind of all get caught up there. And to the students, if I'm going too slow, just write faster. Okay, thanks. All right, so here's what we got. Our eye is just absolutely phenomenal. We can take a look at color, we can acknowledge brightness. We're capable of setting our focus on different images in the same plane, even if they're at different distances. And all of this is because of a very beautiful pathway inside our eye. What's interesting is that focusing, all of it happens at the front of the eye. So using our cornea and our lens, those things are actually, the cornea is responsible for a little bit of refraction, but the lens is actually what changes shape and focuses everything at the front. All of the other processing will always happen at the back of the eye, and then those signals are going to travel through our optic nerve and hit our brain. So there's a lot of things happening here, and we're kind of going to dive into it here. So this pathway, I can't tell you how important this is, and this diagram. So this slide, I would put a gigantic star or smiley face or circle or color it or whatever you'd like to do. You need to know everything that's happening on this slide, including this diagram. Do not be surprised if I ask you to label something about this, or if I ask you the pathway of light in the human eye. Those things are both up for grabs. There's no easy way to remember them other than just study your butts off and you will be fine. Okay? This is a nice little tune-up for biology because unfortunately that's what it's going to be a lot of. It's going to be a lot of teaching yourself good methods in order to kind of understand and be able to recite content. So this slide, super important. All right. Two things that we're going to talk about to start. So cornea is the very first thing that light is going to hit. So it's this like little tissue in front of the eye, and it actually starts this little refraction process here. So if you're writing, I just want you to stop for a second. Can you see my mouse? Yeah, you can. Yeah, I think you can. The cornea is like this little thing going on right here. And if you notice, it actually like slightly refracts the light before like its gigantic refraction that's happening over here. So the cornea is like its very first kind of refraction that's happening. So the cornea, super important because it starts that focus of light. So it starts our refraction process. At the back, the retina. The retina is wicked. See, the retina is almost like this screen on the back of our eye where all of this light is going to get trapped. And by trapped, I mean it's all going to hit the retina, and then we're able to process it because the retina is going to send that information along the optic nerve and into the brain. So the retina is a super sensitive layer of cells that kind of respond to light in a very interesting way and transmit those things using nerve signals into our brain. So really, really cool. So remember, cornea is the very, very beginning. Retina is at the back. So cornea is going to be responsible for the very first refraction and the focus of light. Retina is going to be responsible for taking that information and kind of sending it down our optic nerve. All right. Now, what I'd like you to do right now, before you copy this down, is I'd like you to try something. I'd like you to take a look. Oh, sorry, I'm just getting so many text messages. I'm so popular. What's going on over here? Oh, it's my fans. Sorry. Sorry, I'm just, you know what? I got so many subscribers on my YouTube channel. You know, it's hard to keep up with all the love. Anyway, sorry. What I'd like you to do, hands up, I'd like you to put your hand directly in front of your eye. So like probably about 6 inches from your eye, and I don't want you to look at it. So put it in front of one eye. I don't want you to look at it. I want you to focus on something in the background. All right? Now, notice when you're focusing on something in the background, your hand, which is in front of your eye, is going to become a little bit foggy. It's not going to become perfectly clear. Now, quickly shift your glance and stare at your hand. What's going to happen now is you've adjusted how your lens is actually shaped. Because of that, now your hand is going to be in focus and everything else in the background is not going to be. That's a magical thing. We're able to shift our focus from a distant object to a close object, and it's all because our lens can actually change shape. That's beautiful. You can go back to copy now. Thank you. And in fact, that's the same thing that happens in a camera. So if you've ever taken a photography class, you'll notice it's very difficult to focus on both nearby objects and distant objects unless you play around with the aperture. But our lens kind of behaves in the exact same manner. We like focusing on a single object or a single distance when we look at objects because our lens in our eye actually needs to change shape to kind of adapt and get used to what we're looking at. And if you do that quickly enough, if you go from looking at something like really close, like your hand, to something really far, eventually your eye is actually going to get tired and it's probably going to hurt. And please don't yell at me because it's not good for you. It's not good to keep shifting your focus from one thing back and forth to another. All right. The reason we're capable of doing that is because of something called ciliary muscles. So these muscles are what actually changes the shape of our lens. So these things are super important. If you are very good at shifting between far objects and close objects, your ciliary muscles are jacked. It's great. It's good. You could go into a competition. That's awesome. If not, maybe you have an issue with your ciliary muscles. And actually, as we age, which we're going to see in a couple of slides, our ciliary muscles get a little bit weaker. All right? So Mr. Valconi, who's getting up there, his ciliary muscles are having a really tough time. Okay? Prayers up. When you look at things that are far away, our lens changes shape. We know that. Changes shape depending on what we're looking at and how far that thing is. But what happens is the farther away something is, our lens is actually going to get longer because our light rays are coming from farther apart. So if you look at A up here, our light rays are coming from a much farther distance, which means we need to capture all of that light. So we're actually going to elongate our rays in order to get those rays to converge on a point. This is going to become very clear once you examine lenses a little more thoroughly, which we will. For now, please just remember, distant objects, our lens will become elongated, so thinner and longer. For nearby objects, light is coming from a much closer source, which doesn't give those light rays time to spread apart as far, which is great for us because now we can actually make our lens a little bit thicker and shorter, allowing us to focus more precisely on that close by object. So please know this. These seem like a good multiple choice or true and false question or something that you could be asked later on in your life, so it's important. Oh my gosh. Guys, look at this. Look at this. So if you look at like the number 5 in your camera, what happens is that 5 on the camera is actually going to be flipped upside down. And then the camera is smart enough to be like, I know that thing is not flipped upside down. So in its image processing, it actually flips it right side up, which is great because it saves you like having to flip around your camera to look at all of your images. Now, your eye does the exact same thing. If it has a right side up 5 in real life, we actually see that thing in our retina as being upside down. So if you look around you right now, your retina is observing every single thing you're looking at upside down. So you are indeed sitting on the ceiling. Now, our brain is smart enough to be like, I know that that's not how this works. So it flips everything right side up before we even have a chance to acknowledge it as upside down. But when we see things, we actually view them as a real image upside down, and our brain flips it right side up. Isn't that cool? I know, thanks. All right. Some of you wear glasses, and that's cool because it might help you fix problems like this, myopia, which means nearsightedness. Now, there's going to be a couple of slides like this. You need to know these 3 things that I've posted up here. So this bold stuff. Myopia means nearsightedness. Know that. This means your eye is too long. That's not great because it doesn't allow you to focus on distant objects. So even though it says nearsightedness, this refers to what you are good at. You're good at seeing things that are near. You're not good if you have nearsighted at focusing on things that are far because your eye is just too long. So what do we do to fix that? Well, we can use glasses, and glasses have lenses. So we can use those lenses. If we put those in front of our eyes, they can actually adjust how far those light rays are coming from, and then we'll actually be able to see them a whole lot better. And if that doesn't work, we can always use surgery to fix those up. So nearsightedness, we have a very long eye, means it's hard for us to focus on those distant objects, and we can use a concave lens to fix it, or surgery. So please know this slide and the next slide, which is its fun brother. Hyperopia, which means farsighted. So remember, that refers to what you are good at seeing. So farsightedness means you can see things that are far, you can't see things that are close. Here you have an eye that is far too short. All right, so we can use something to help us fix that. We can use something like a convex lens to help us fix that, also called a converging lens, or surgery. So this would be if you have trouble like reading the newspaper. You do not read the newspaper, I imagine. Maybe if you have trouble like reading your MySpace news feed, then you might have something like hyperopia, which is farsightedness. Okay, so to fix it, surgery or the lens. Please know those slides. Okay, this is the Mr. Valconi disease, presbyopia. When we get older, your ciliary muscles are not going to work as well. So you're not going to be able to change the shape of the lens, which means you're going to have trouble focusing on stuff, especially things that are nearby, because that puts a little more strain on our eyes. So we're not going to be able to focus on those nearby objects. They're going to appear blurry, and lots of times we use glasses to help those things out. So we can actually use something called bifocal, bi meaning two, so two focus glasses, for people that are already nearsighted. So it kind of helps them out twice. So presbyopia, it's when the ciliary muscles become stiff and they're not able to kind of fix those lenses up as we need them. All right, and I think the last problem is astigmatism. So an astigmatism is when you have a misshaped cornea. So the cornea should be, in theory, round. If it is not, it is oval shaped, and here you're going to need some type of lens in order to fix you up, or you're going to need surgery. This does not look like something that is a ton of fun, so I think that most medical professionals would be very interested in figuring out the best way to deal with this situation. So lenses or surgery, and surgery is getting better and better with every passing day, so I imagine most medical professionals would lean to surgery for willing candidates. Why? Because surgery is wicked. Look at this. Look at this. Huh? 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 I know, man, it's wicked. So surgery means we use like this laser, these like wicked laser beams to actually vaporize. So we just literally like almost melt / like evaporate parts of your cornea. So that very small, very first step to your eye is actually going to be vaporized. We can actually change its shape by vaporizing this. So you're going to cut like this small little flap, pull it back, and then go to work. Vaporize this thing, get it to the shape that you want, and then we just replace that flap. And you're in and out. It's a really cool process. It's so far above my scope of knowledge, but like just even reading this, like I hope you're interested, because it's amazing what we're able to do. And then, oh, yes, okay, so this. You probably won't be able to hear this, which is unfortunate. But I'd like you to watch this. So this is posted on the LMS inside this presentation. So if you're going back and you're taking a look at this, take a look. This guy is awesome. He does a really good job. But he's like, it's a little creepy. So just be ready for that. Anyway, I hope this was fun. If you like this video, just make sure to click subscribe there below. And yeah, all right. Thanks, fam. Bye. How do I stop?